analytic function. Of analytic function. Definition. The point Z0 is called a singularity point. Of the analytic function f of z. If f of z is not defined at z0. When you have a function that is not defined at a point, it means that you cannot get a real value. That's what it means. It means that point is a singularity point. So, when z0 is equals to any of these z0, if it is equals to 0 over infinity, infinity over 0, 0 times infinity, all these points are not defined. These are all singularity points. Is that okay? Yes. So you can't get a concrete value. For example, if your f of e.g., if your f of z is equals to sine z over z, is that okay? F at 0 is equals to sine 0 all over 0, which equals 0 over 0, which is undefined. Is that okay? So which implies that z, which is equal to 0, is a singularity point of f of z equals to sine z all over 0. Is that okay? That's a singularity point. Also, if you have, for example, 2, let's say 1, this for example, 2. If you have your f of z, which is equals to z minus 1 all over multiplied by e raised to power z minus 1. Is that okay? When z is equals to 1, what do we have? Our f of z will be equals to what? 0 times this is 0. No, let me write. No, I want to write. Let's write it like this. This one will be e raised to power 1 all over 0, which is equals to 0 multiplied by e raised to power infinity, which is equals to 0 times infinity. It's a singularity point because there is no value like 0 multiplied by infinity. So these are all possible. Now we have what we call classification of singularity points. So all these singularity points, we can classify them. Is that okay? The first one is what we call removable singularity points. The point Z0 is called a removable singularity point of f of z if f of z is not defined at z0, but the limit as z tends to z0 of f of z is equal to a particular value which is less than infinity, which is not equal to infinity. So here, even though the function is not defined at Z0, but at the neighborhood, Z tends to Z0 means at the neighborhood of Z0, it has a limit. Is that okay? For example now, you know, like f of z is equals to sine z over z. Z is equals to 0 is a singularity point, I mean, like we showed in where, because you are when z is equals to 0, you are going to have 0 over 0. But look at when we take the limit as z tends to 0 of sine z all over z. This one is equals to limit as z tends to z as z tends to 0. What is sine z? Sine z is z minus z cubed all over 3 factorial plus z5 all over 5 factorial minus and so forth. Everything all over z. Is that okay? And you see that this one is going to give us what? 1. Because this z will cancel this z, so will give us 1. This z will cancel the z squared, z4. But when z tends to 0, all other ones will go to 0. Okay, then the limit will go. So you see that this one is less than infinity. So which implies that z is equals to 0 is a removable singularity point of f of z, which is equals to sine z over z. Is that okay? Yes. Then the second classification is what we call a pole. Pole. The point Z0 is called a pole of f of z if the limit as z tends to Z0 of f of z is equals to infinity. You know that infinity also is an undefined value. Yes. There's nothing like infinity. It's extremely big, but how big we cannot say. Right. It is not. So when you have that one, then we say that Z0 is a pole. It's a pole. We call it a pole because if it is this, you go to infinity, you go to infinity. So what we have here is like a pole. That's why we call it a pole. Now, e.g., if your f of z is equals to 1 over z, for example, you see that the limit as z tends to 0 of 1 over z is equals to 1 over 0, which is equals to infinity. Is that okay? So Z0 is a pole. You understand? This is 1, 2. If your f of z is equals to cos z all over z, for example, you will see that the limit as z tends to 0 of cos z all over z is equals to cos 0 all over 0, which is 1 all over 0, which is also infinity. Cos 0 is 1. Is that okay? Yes. So you see that we have a pole. We also have a pole. So that is a pole. Then the third classification, the point Z0 is called a pole of order n of the analytic function f of z if z naught is a 0 point of order n of phi of z, which is equals to 1 over f of z. So if you want to find the order of a pole of f of z, you first of all take its inverse, 1 over f of z. Whatever you get is will be your phi. Is that okay? You take the inverse, you get your phi, then you look for the 0 point and its order. Okay. By the time you get the order of the 0 point, that will be the order of the pole of f of z. So the order of the 0 point of f of z is the order of the pole of phi of z is the order of the pole of. For example, now, if your f of z is equals to 1 over z squared, is that okay? Yeah. You know that z is equals to 0 means implies f of z is equals to 1 over 0, which is equals to infinity. Which means that z naught is a pole. Z naught is a pole, I mean? Yes. Of f of z. If you now want to find the order, you take your phi of z, which is equals to 1 over f of z, and this one will give you z squared. Is that okay? Yes. And you know that here, so your phi of z is equals to z squared. Z naught equals to 0 is a 0 point of order 2, because if you find the first derivative, you get 2z. If you find the second derivative, you got 2, which is not equal to 0. So it's of order 2, which implies that z is equal to 0 is a pole of order 2 of f of z. Okay. So I will stop here today by talking about essential singularity point. The point z naught is called an essential singularity point of f of z if it is neither a removable singularity point or a pole. So if a singularity point is not a removable and is not a pole, then it's essential singularity. For example, f of z is equals to z e raised to power 1 over z. Is that okay? You see that when z is equals to 0, we have that f of z is equals to 0 times e raised to power 0, which is equals to e raised to 0 times e raised to power infinity, which is equals to 0 times infinity. This is not a removable, no, it's not a pole. So it's an essential singularity point. Is that okay? So z is equal to 0 is an essential singularity point of f of z, which is equal to z e raised to power 1 over z. So maybe we stop here today.